This lesson is on finding and graphing the inverse of a function. You should take notes on this lesson in your notebooks, and you should use those notes as a resource when you're doing your homework problems. First of all, let's define what the inverse of a function is. The inverse of a function is the function or relation that results when we interchange the range and the domain. That is the basic definition of the inverse of a function. Now the symbol that we use for the inverse of a function is f to the minus 1 for the function itself, or we can use f to the minus 1 of x for the inverse equation, the equation of the inverse function. For the inverse function, f to the minus 1. For the equation of the inverse function, we use f to the minus 1 of x. Now, this is functional notation. This is not your usual algebraic notation. In basic algebra, a number to the minus 1 means the reciprocal of that number. But this is not the case when you're dealing with functional notation. In functional notation, f to the minus 1 does not mean 1 over f. It doesn't mean that in functional notation. It just means the inverse of f. That's how you would read this. You would read this as the inverse of function f. You just read it as the inverse of function f. It has nothing to do with the algebraic notation of something to the minus 1 power. So this is one thing that you have to realize when you're working with functions and functional notation. You have to realize that you're in functional notation, so it does not mean the same thing that it meant in basic algebraic notation. The same thing here. This means f inverse of x. You can say f to the negative 1 of x, or you can say f inverse of x. That's how you can read this, as f inverse of x, the inverse function of x. So please keep that in mind as you proceed with inverse functions, that f to the minus 1 does not mean 1 over f. It's just functional notation. It means the inverse of function f. So as we stated here, you get the inverse by interchanging the range and the domain. So if I have a function f, and this function f is equal to the set of ordered pairs 4, 1, 6, 3, and negative 2, 0. To get the inverse of that function, to get f to the minus 1, which is f inverse, I would interchange the range and the domain. Of course, you recall the range is the y values, the domain is x values. So I interchange these two values. So instead of having 4, 1, I would have 1, 4. And instead of having 6, 3, I would have 3, 6. You see, you're interchanging the x's and the y's. That's how you get the inverse of a function. And like so. Now, the inverse of a function is not necessarily a function. When you interchange the domain and the range, the result may not be a function. So you have to be aware of that when you're working your problems. So you have to really be careful there. Okay, so for example, if I had something like this, if I had a function g, okay, and the function is 1, 3, -2, 7, -4, 3, and 2, 1/2. Okay, if I look at that, none of my first components are the same, so this would be considered a function. If I get the inverse of this function, g to the -1, which means g inverse, I would then change the range and domain. So I would make this, instead of 1, 3, I would have 3, 1. Instead of -2, 7, I would have 7, -2. Instead of instead of -4, 3, I would have 3, -4. Instead of 2, 1/2, I would have 1/2, 2. I look at my order pairs of numbers for the inverse of this function here, and I see that these two order pairs here have the same first component. So that means that g would not g inverse would not be a function. So you want to keep that in mind, that the inverse of a function is not always a function. So this is dealing with ordered pairs. This is how you get the inverse of a function if you have ordered pairs of numbers. If you have the equation, then you do that by interchanging x and y, and then solving the equation for y. So for example, if I have the function f of x equals 3x plus 6, this is a linear equation, as you can see, and it is a function. If I want to find the inverse of that function, let's say find the inverse of f of x. I want to find the inverse of that function, find the equation of that function. So I'm looking for, this is the same thing as find f to the -1 of x, which means f inverse of x. Now, to get the inverse of a function, once again, you don't put 1 over the function. To get the inverse of a function, you interchange the range and the domain, which, in terms of equations, that means interchanging x and y. So that's what we have to do here. First of all, we recall that f of x is the same as y. So this equation here can be written as y equals 3x plus 6. So first, when you are finding the inverse of a function, you have to substitute y for f of x, because y is the same as f of x. Okay, then you have to solve the equation. Well, you have to interchange the range and the domain. So you have to interchange x and y. Let's write the steps on the side here. Steps number 1, we replace f of x with y. That's what we do first. Replace f of x with y. Okay, then step number 2, keeping in line with the definition of an inverse function or the inverse of a function, we interchange x and y. Step number 2, interchange x and y. Now this is a telecourse tape, so you can feel free to stop the tape at any time. You can feel free to turn the tape back if you need to, if there's something that you didn't get, and what have you. So we interchange x and y. So here's y. We take the x and put the x here in the place of the y, and here's x. We put the y in the place of the x. So we interchange the x and the y. We put the x in the y's place and the y in the x's place. That's how you get the inverse of a function. So once we do that, the moment we do that, we have the inverse of that function. But you have to write it using functional notation. So that's why we have to continue. So after you replace the f of x with y, you interchange x and the y. So next step, we have to solve for y. Step number 3, you have to solve for y. So to solve this for y, we subtract 6 from each side. We get 3y equals x minus 6, and then we divide each side by 3. We get y equals 1/3 x minus 2. So now we have solved the equation for y. Now this is the inverse function. We want to be able to distinguish the inverse function from the original function. Now we know that y is really the same as f of x, but you see, if I want to write this in functional notation, if I put f of x here instead of y, I would confuse it with the original function. So this is why once you solve the equation for y, you have to replace y with f to the minus 1 of x, which is called f inverse of x. So step number 4, you simply replace y with f to the minus 1 of x. So my final step here, I would have, instead of y here, I would have f to the minus 1 of x equals 1/3 x minus 2. And that is the equation of the inverse function. And that's how I represent the equation of the inverse function. Okay, now we want to be able to graph the function and graph the inverse. You want to do those two things. You want to graph them in the same rectangular coordinate system. Now you're going to have some problems similar to these for homework. So be sure to copy this example down so that when you start doing your homework problems, you can use basically the same procedure I'm using here. Now, to graph the function, f of x equals 3x plus 6, we can see that it's a linear function, so all we need to do is find 2 points and then graph those 2 points and draw a line through those 2 points. So let's do that and see what that graph of the function looks like. So for the graph of the function, we make a solution table in order to graph our function. We make a solution table, x, f of x, and then we only need 2 points here, so let's use 0 and -1. We use 0 and -1 for our 2 values of x. So first we want to find f of 0. F of 0 would be equal to 3 times 0 plus 6, and that would give us 6. Next we want to find f of -1. That would be 3 times -1 plus 6. 3 times -1 is -3, plus 6 will give us 3. So we have the 2 ordered pairs, and that's all we need to graph a line, just 2 ordered pairs of numbers. So we go over to a rectangular coordinate system, and we put some notches on there. 1, 2, 3, 4, 5, 6. Now, if you have graph paper, of course, your graph will be more accurate. So if you have graph paper, be sure to use that. Okay, and then we just graph the points that we have. For my first point, I would start at the origin, and I would go no points right or left, and I would go up 6. 1, 2, 3, 4, 5, 6. So that would be the graph for my first point. For my next point, -1, 3. 1, 2, 3. I go 1 to the left and up 3. Please check behind me on my solutions here, and I'm working out of the different values for f of x here. Then I draw a line through my 2 points. Now, that is the graph of the function. So this is the graph of f of x. Okay, so we'll put f of x by this graph, since that's the graph of f of x. Or we can just put f for the function f. Now we want to graph the inverse function. Now, to graph the inverse function, class, we could go through the same process that we went through there, but we know what the inverse function means. It means that you interchange the range and the domain. So instead of going through the same process of finding 2 points, all we have to do is go back to the solution table and just interchange x and y, and then graph our points again. So that's what you do when you're graphing the inverse function. You graph the function just like you did before. If it's a quadratic function, you write it in standard form, you get the vertex, the axis of symmetry, and then you finish the graph. If it's a square root function, then You find the x-intercept, and you find a couple of points, and you draw the graph. And then to get the inverse function, you just go back to the solution table, interchange x and y, and then graph the inverse function. So just follow what we do here to get the inverse function. So we want to graph the inverse function and the function in the same rectangular coordinate system. This is the function f. This is the function f represented. So f inverse, we would have x first, but instead of f of x, we would have f inverse of x. You see how the solution table looks for f inverse? For the solution table for the function f, you have x f of x. For the solution table for f inverse, you have x f to the negative x, f inverse of x. And you interchange the range and the domain. So here you had 0, 6. Now down here, you're going to have 6, 0. See, we don't have to plug in numbers again. We just go back to the same solution table and interchange our x's and y's. We have -1, 3, so here we're going to have 3, -1. And then all we do is graph these points, and the graph will look very similar to the one we have there. In fact, usually when you graph the inverse function and the function, they look very similar to one another. So to graph the inverse function, we start at the origin. We go 6 to the right, 1, 2, 3, 4, 5, 6, and we stay there. For our next point, we start at the origin. We go 1, 2, 3 to the right, and then we go down 1. So those are the points for our inverse, and then we know it's a linear function, so we draw a line, straight line through the 2 points. Now your inverse function and your function, they both should look very similar to one another. So if they don't, then that's a tip-off that there's something wrong, that you need to go back and check your work, make sure that you did everything right. So this is the graph of the function in the inverse, and we labeled this one f to the -1 of x, just to show the difference between the function and its inverse on the graph, so that we can look at the graph, we can see which is which. Now, one thing you should notice about a function and its inverse, they are symmetric with respect to the line y equals x. So the line y equals x come out here like this. This is not a part of the graph, but this is just some additional information on inverse functions. The line y equals x would split the first quadrant and the third quadrant in half. And when you look at the line y equals x, you will have the mirror image of one function on the other side of that line y equals x. So this part over here of our inverse function looks just like this part of our original function. You see, you have the mirror image on the other side of that line y equals x, and the same thing down here. This part looks just like that part of the inverse function. So that's something else you should notice about the graphs of inverse functions. If you graph 2 inverse functions, if they're not symmetric with respects to, if your graphs are not symmetric with respects to the line y equals x, then that's another tip-off that there's something that went wrong there. So this is the process for finding and graphing inverse functions. Once again, the first thing you have to do, you have to replace f of x with y. After you do that, you have to solve the equation for y. After you solve the equation for y, then you have to replace y with f to the -1 of x. After you do that, you graph the original function, make a little solution table, graph the original function, and then after you graph the original function, you take the same solution table, but you switch the x's and the y's around, and then you graph your new order pairs, and that will be the graph of the inverse function. You want to graph both of those in the same rectangular coordinate system. Okay, so this is finding and graphing inverse functions. Another thing we want to talk about is how do you tell when a function is an inverse function? How to tell when a function or an equation is the inverse of a given function or given equation. How to determine if one equation is the inverse of another. Okay, to determine if one equation is the inverse of another, we have this rule here. If let's use g. Okay, let's say if g of x is the inverse of f of x, then f of g of x is equal to g of f of x, which is equal to x. Once again, if two functions are inverses, then if you substitute one function into the other, and then substitute the other into the original function, you will get the same value, and that value will be x. So this is how you can tell algebraically whether or not two functions are inverses, or whether or not two equations are inverses. For example, suppose I have f of x equals 1/2 x plus 2, and suppose I have g of x equals 2x minus 3. And I want to determine whether or not these functions are inverses of one another. I know that this has to be true. F composition G, which is what this is, F composition G has to be equal to G composition F, okay, which has to be equal to x. So all I have to do is substitute G of x into F of x and see whether or not I get x, and then do the reverse, substitute f of x into g of x and see if I get x. So first I'll find, okay, so let me put the question up here so you have it in your notes. Are these inverses? Are they inverses of one another? That's what we want to know, whether or not these two functions are inverses of one another. Okay, so first let's find f of g of x. Okay, f of g of x, that means substitute g of x into f of x for x. So that would be the same as 1/2 g of x plus 2. You see, because we're substituting g of x in here for x. Here's x. We put a g of x here instead of x. So that will give us 1/2 g of x plus 2. And then we substitute the expression for g of x. So we get 1/2 times the expression for g of x is 2x minus 3 times 2x minus 3 plus 2. And then we simplify that. Okay, 1/2 times 2x is x, 1/2 times negative 3 is negative 1 and 1/2, and then we have plus 2. And then we simplify it further, we get x plus 1. So that is what f of g of x is. F of g of x is equal to x plus 1. Now, at this point, we don't have to go any further. We know they're not inverses, because if they were inverses, f composition g would have to be equal to x, or f of g of x would have to be for x. So these functions are not inverses, so we don't have to go any further. They're f of x and g of x are not inverses of each other. They are not inverses of each other. So if you find that you compose one function on the other, f composition g and g composition f, if they are equal to x, if both are equal to x, then they are inverses. So you'll be interested in doing some problems related to this lesson. It's problems related to finding and graphing inverse functions, and also problems related to this topic here, finding out or determining whether or not two functions are inverses. If I have an example like this, let's say I have f of x equals x minus 5 and a g of x equals x plus 5. And I want to know whether or not these functions are inverses. Are they inverses of one another? So of course, if one is the inverse, the other one will be the inverse of that one. So we find f of g of x. For f of g of x, we substitute g of x into f of x for x. That's what f of g of x means. So we would have, instead of x here, we would have g of x. So it would be g of x minus 5. G of x minus 5. But of course, g of x is really x plus 5. So here we substitute x plus 5 for g of x. We get x plus 5 minus 5, and that gives us x. So it looks like these two functions are inverses, but just to be on the safe side, let's do g of f of x and see if we also get x. So g of f of x means substitute f of x into g for x. So this time we're looking at g and we substitute f of x, so we get f of x plus 5. Of course, f of x, the expression for f of x is x minus 5. So we substitute that in there, we have x minus 5 plus 5, and that gives us x. So then we make our final conclusion for this second example. We say that since f of g of x is equal to g of f of x is equal to x, the functions are inverses of one another. Functions are inverses of one another. So they were inverses, the functions were inverses of one another in this case. So this is the process that you have to go through in your homework. Once again, I hope that you have taken notes on this tape. If you have time, you may feel free to play the tape again. If you have time, you may feel free to play the tape as you do your homework problems to make sure you're doing each step correctly. Thank you for joining us. Have a good day.